All right, guys, these next two lessons should be very, very easy and familiar. We're reviewing basic trig, so we get to some more complicated trig. So this is your formula sheet, cheat sheet. Keep it safe. You'll be able to use it on your tests. All right, so don't lose it. All right, Pythagorean theorem. You should know this by heart. A squared plus b squared equals c squared. Only thing you have to realize is c is always your hypotenuse. So leg squared plus leg squared equals hypotenuse squared. Real basic right here. 4 squared plus 8 squared is x squared. Now we are dealing with triangles here, so even though this is a square quadratic equation, basically it has two answers, the positive and the negative. We're only looking at the positives because a negative side length just doesn't make sense. So just use your calculator. 4 squared, go back here, 4 squared plus 8 squared. That's 80. Square root of that is 4 squared root of 5. So that's 80 equals x squared. 4 square root of 5 is x. Now, you are responsible for simplifying these radicals. If you don't have a calculator that does it for you, make sure you can use a factor tree to do it. 8 and 10, 4 and 2, 2 and 5, 2 and 2. We've got two pairs of 2's here. 2 times 2 is 4. 5 is all by itself on the inside. So you are expected to simplify your answers. Calculator should do it for you if you have the right one. Let's check. Yep, here 24 is our hypotenuse, so make sure you do 22 squared plus x squared equals 24 squared. You can put the x squared first. Whichever leg you start with does not matter. So let's just use our calculators. 22 squared is 484. And that's 576. Use your calculator to subtract. Squared is 92. And see if that has a nice square root. 2 squared is 23. It is. And again, we're only looking at the positive solutions. If this were a pure algebraic equation, it would be plus or minus 2 squared to 23. However, since we have context, this triangle here, we're only looking at the positive. 2 special right triangles you should memorize. Lucky for you, this calculator lets you not memorize them because it knows that sine of 30 is a half, and sine of 60 is square root of 3 over 2. But for those of you that decided not to get the calculator I told you to, here's 2 special right triangles that will let you know any 45, 30, or 60 sine, cosine, tangent, or the other 3 we're about to learn, angle. So if we have a 45, 45, 90, that's isosceles triangle. And the ratios are 1x, 1x, square root of 2x. So let's give an example. If 45 here, across the 45 here was a 1, this would be 1, 1, square root of 2. However, to make our lives easier, we're going to let the hypotenuse be 1. Let's see what happens. So this is 1. To go from the hypotenuse to a leg, you could use Pythagorean theorem. X squared plus x squared equals 1. And if you do, you'd get the same result. 1 divided by square root of 2 is square root of 2 over 2. And that's what we're going to use. Reason being, what's the denominator on sine and cosine? Hypotenuse, right? So if we have the hypotenuse as 1, it makes these easier to use. But again, don't need to worry about it if you have a calculator that does it for you. 30, 60, 90, across from the small side is x, hypotenuse is 2x, and x squared to 3 is from the long side. So we're going to let 1 be my hypotenuse again. Guys, this is not whatever. Always go from whatever you're given to your short leg. Don't try and go from hypotenuse to long leg. It's just not going to be pleasant. So to get to my short leg, I divide by 2, I get a half. And if I go a half times square root of 3, well, that's square root of 3 over 2. But again, your calculator knows that, well, let's see, opposite over hypotenuse, that's sine. So sine of 60 should be square root of 3 over 2. And it is. So the short leg, we call that a half. The longer leg, square root of 3 over 2. And the hypotenuse is going to be 1 for us. Now there's other ways to remember it. Just if you can remember it, you can manipulate it. So if you remember 1, 1 square root of 2, 1, 2 square root of 3, that works as well. If you have a calculator, that works even better. So we're just going to practice here. So we're going to use these rules right here. This is a 45, 45, 90. So whatever this leg is the same as this leg. That makes that 10. And we know it's square root of 2 times that. So 10 square root of 2. We know 16 is my hypotenuse. So if I take my calculator, 16 divided by square root of 2 is 8 square root of 2. Those. Here, that's easy. That's 14 on both. Here, oh wait, that's a 30, 60, 90. Across from this one is the short leg, which is half of the hypotenuse. So the hypotenuse is 8. That makes that 4. Long leg is, or also 60 is 4 times the square root of 3. Right over here, we're given the long leg. The long leg is whatever x is times the square root of 3. So we need to divide by square root of 3 to find out what our short leg is. 9 square roots of 3. So right there, y is 9 square roots of 3. If we double that, we get x. Now you could use, basic trig just to solve these as well. And that can stop you. However you want to do it, do it. Remember those special right triangles? You can save yourself some time. Over here, 30 is right here, so this makes 5 square roots of 6 my short leg. If I double that, I get my hypotenuse, which in this case is 10 square roots of 6. And if I multiply that by square root of 3, I get 15 for my long leg. 5 square roots of 6 times square root of 3 is square roots of 2. Yeah, okay. I forgot the spreadsheet. Sorry. Just use a calculator. It's much safer. All right, you should know your basic functions, sine, cosine, and tangent. Guess what? There's 3 more. Cosecant, secant, and cotangent. Those are just reciprocals of sine, cosine, and tangent. Now, we're always going to use the Greek letter theta. Well, not always, but a lot of times we use the Greek letter theta to represent an angle. It's like we use x in algebra to solve for a missing variable. Now, if we look at this triangle, sine, remember, some old hippie caught another hippie tripping on acid. That's an automatic I always use. If you don't like it, whatever, I don't care. Sine is opposite over hypotenuse. That's what SOH stands for. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. I don't care how you remember it, just remember it. Guess you kind of need to know what opposite adjacent and hypotenuse are too. If you forgot, hypotenuse is a crossing right angle. Now, which one is opposite, which one's adjacent, depending on which angle you're looking at. So this is the angle that we're having here. We're looking at this angle right here. But when it does not touch, if you arc it, is your opposite. And that leaves one left to be your adjacent. Sine being opposite over adjacent would be A over C. Oh, sorry, sine is opposite over hypotenuse, it's A over C. Cosine is adjacent over hypotenuse, that's B over C. Tangent is opposite over adjacent, which is A over B. Reciprocate those, and you get your co-function, your reciprocal functions. Hey, it's in the name. So 1 over sine, if you 1 over A over C, it just flips it, inverting it, reciprocating it. C over A. That looks like a 4. C over B, and B over A. So these are the 6 trig functions we'll be dealing with. Make sure you know how they're related. You do have your cheat sheet here that has them on there under reciprocal identities. Anyway. So let's take a look here. So we're given 2 sides, 2 legs of a right triangle. How are we going to find the third triangle? Right, the third side. Pythagorean theorem, that's right. A squared plus B squared equals C squared. Just do the math in your calculator real quick like. $34. Okay. So now that we have all of our sides, we can get our ratios. Sine is opposite, and we're talking about theta here, so that's opposite, that's hypotenuse, and that's adjacent. And I notice all these have a 2 in them, so these will simplify. 16 over 34 for sine. That's like 8 over 17. Yeah. This is sine, this is cosecant. Well, if you don't remember, cosecant is the reciprocal of sine, right? So flip it, 17 over 8. Cosine, that's adjacent over hypotenuse. That's 30 over 34, which is 15 over 17. And secant is 17 over 15. Tangent, opposite over adjacent. So that's 8 over 15. Cotangent would be 15 over 8. All right, so let's go ahead. We're given one trig function here. Let's draw a triangle. I'll put theta there. You can put theta elsewhere. You can put theta up here if you wanted to. Just make sure you mark one of them as a right angle. Now this is my hypotenuse, which means that is 3. This is my adjacent, which means that's 2. So that makes this, let's see, 9 minus 4 is square root of 5. Pythagorean theorem now. Call that x. X squared plus 2 squared equals 3 squared. 9 minus 4, x squared is 5. Square root of 5 is so real quick, like square root of 5 over 3. This is going to be square root of 5 over 2. This is going to be 3 over 2. And now type it in your calculator. 3 over square root of 5 is 3 squared is 5 over 5. And this will be 2 squared is 5 over 5. Nothing too complicated there, right? And, you know, we should just be able to look back right here at these we did right here. Sine and cosine of 45 both square root 2 over 2. And if we look at this one, sine of 30, opposite is the short leg, so that's a half. Cosine of 30, square root of 3 over 2. So to flip around for the 60. So these are used a lot. That's why you should memorize them, or the special right triangles to get them. If we divide something by itself, that's obviously 1. Oh, did you realize that tangent is sine over cosine? If you didn't, pretty sure it's on here. Yeah, tangent sine over cosine. You can think about why. Sine is opposite of hypotenuse. Cosine is adjacent of hypotenuse. If you divide those, hypotenuses will cancel. Sine of 30 is a half. Cosine of 30 is square root of 3 over 2. Tangent 30, tangent 30, well, that's 1 over square root of 3, which is square root of 3 over 3. Sine of 60, that's square root of 3 over 2. That's a half. And if we do that, that's square root of 3 over 1, which is just square root of 3. So that comes back from those two triangles we just drew a minute ago. All right, so these we use a lot. You can memorize them. You can use your calculator. So don't fret. It tells you. Now, if you don't have that calculator, you can memorize it. But for now, see ya.